Sure. Oh, I need to fix that. Hello, class. Okay. How's everybody doing? Hello?
All good.
Doing good.
Doing all right yourself?
Doing well.
All right. Everybody took the test, the quizzes and everything?
Here.
Yes.
Yes, but I have a, like the question 33, the correct answer is wrong.
But what number? Well, not say a number, but what was the question? That wasn't the 18 point something by 4.
18 divided by 4.
You're
The
right.
correct answer
Five.
should be
Okay, go ahead. What the answer should be? Go ahead. I'm listening.
yeah. 18 divided by 4. Correct answer should be 4, not 2, because it's not.
Correct.
Right.
Yeah, I fixed it though. Right, because I had another student. What's her name? I think Ms. Martin. She had contacted me about the answer, and she said it should have been 4.5. So when I looked at it, and she had took a screenshot, and I looked at it, and I say 2. No, it should be 4. You know, so I emailed her back, but I think she was, and then she was still wasn't clear on it, because the reason why it's going to be a whole number is because X was declared as what?
An integer.
As an integer, right. So once X is declared as an integer, no matter what happens on the opposite side, it's going to only what? Receive a what? Receive what? An integer, right? Right. But remember, we talked about promotion in the previous lesson, but it would, if it was a float variable on the left side, then what? It would have sent what? 4.5, correct? No, yeah, 4.5. But being that X was int, it's gonna only store 4, and you would get an output of 4, right? But you're right, Mr. Muhammad. And what I did though, I went back and it gives us an option to go back on our questions and modify the answer, then it asks us if we want to allow the student's test to be modified. And I said yes. So it should have modified your test score. All right.
I had a question as well.
Okay, what you got?
On one of the questions, it was on one of the 4-score and 7 years ago questions,
Uh-huh.
and which on how it would see out format correctly. On one of them, there was 2 answers that were pretty similar. One had a
BR.
it was a I'm sorry.
It had that BR at the end of it.
It was the one that had the \n instead of the /n for the new line.
Uh-huh.
But on the answers, there was one that displayed the \n instead of the /n, but it showed a space in between years and ago. But the other answer, but the format it showed, which was the correct answer, the correct answer was that there was a space between years and ago, but in the format on the question, there was no space between years and ago, but there was 2 answers to that question that were very similar. I got the answer correctly. I just wanted to ask.
Okay. You. And I could look at that one, write that one down and see.
Because one of them displayed a new line, but it also did not display it did not have a space between years and ago. But it was supposed to not be a new line, but it did show the space on where it wasn't supposed to be on the correct answer.
Okay.
I think on mine it was number 38, but I think it changes.
Right, it does. But what I could do, I could go to yours and look at it and then go back. Yeah. And that's Mr. Law or Cavalier?
Yes, sir. I got the question right. I was just wondering if it was, other people might have had issues with it or whatever.
Right. Okay. Anybody else? Anything else? All right, so let's, if I'm not mistaken, the next chapter. Let's see. Next chapter. All right. We deal with expressions. Well, and we pretty much got that, but let's go over that. Let me share my screen. Okay. All right, so this is the next chapter. Let me take this up. And do I want this? View. All right, so chapter 3, expressions and interactivity. Now, interactive expression is going to be dealing with mathematical expressions, okay? And I think the program that I give you had some expressions like 2a plus 4b plus 2ab, whatever. That's somewhat of an expression. But we're going to look at expressions a little bit deeper. And also interactivity. Interactivity going to be dealing with C in, C out. You as a user, or you as a programmer creating interactive programs where users can input data. All right. So, and that can be done using the Cn statement, okay, to input from the keyboard. So the Cn object can be used to read data type at the keyboard. And I think we have done some of that. Let me load this. Let me load visual. I'll just open up one of these, say sample 1. something that's already open. All right. Come on. Come on. All right. So, given this, okay, this is, we do pound include, we do using namespace, and do int main. It's our shell. So, doing something interactive, I could do something like int age, and then I could say cout enter your age. All right, and I do want you to put spaces so where it's more readable. Like say you don't want information to be all jumbled together where a person got to guess where something ends or begins. And then I could say cn age. All right, and then you can do cout. And like I said, I didn't put any ifs or nothing in there because we ain't got to that yet. And I'm just tabbing this over. Okay. And I'll just say, all right. So I didn't put anything else in front of it. Hello, somebody, whatever. But I'm just showing you how you can interact with a computer. So int age, so we have a variable that's of integer. Cout, enter your age. So now the computer will prompt the user to input something. And that's a key thing. Anytime you use a cn, it should be preceded by a cout. Why is that? Because just to have a prompt on a screen, the user really don't know or won't know what it actually is for them to do. Okay, so example, let's run it the way it's intended. So we'll debug it, we'll just run it and see what happens. So it'll come up, right? If it ever run. All right, enter your age, okay? So whatever we put 28, okay? You are 28 years old. So see how it took that value from being typed in from the keyboard, and then now I can use it however I want to use it in my program. I could have used it in an expression. I could have used it to do something else if this is greater than or less than whatever. However, but see that it allowed me to input something from the keyboard. But now, like I said, a CN should always be accompanied by a cout. Now, let's look at this same program. Say that you were working at a company and for whatever reason you forgot to put a cout before this CN. And let's run it and see what happens. So this program running. Now, we have a cursor that's blinking. What does that mean? Is the program stuck? Is the program continuously in a loop? Or what's going on? As a user, you really what? You really don't know. So that's why we say no, most often than not, a CN statement will be accompanied with a cout statement. All right. So I could put 28 now, but as a user, I don't really know exactly what is needed. Is a number needed? Is a name needed? Is a letter needed? I don't really know. But I'm gonna just go ahead and put 28 and look, it runs. But really, I didn't know what the program was asking of me. Okay, so that's why you would have the cout precede a CN. Okay, now the document. So that's basically what this information is telling you using the CN statement. So here we have a sample program. We have something with declaring length, width, and area. So rather than write a program where we say length is equal to 5, width is equal to 7, and then somewhere in the program we say area is equal to length times width, where it'll be 7, what I said, 7 times 5 and give you 35, then give you 35. When you write a program where a user is inputting values, you make your program more versatile, okay? Because if I would put values on length and width and not input them, then every time I run the program, I'm gonna get the what? Exact same answer, all right? But when I use a CIN and Cout, all of a sudden now, every time this program or this code runs, I can get what? A different result, okay? Depending on what I put in the computer, okay? So, and an example of that would be if I did this, int age equals 28, or I'll say equals 10. I'll say 10, and I'll comment this out, or I'll comment both of these out. All right, so I'm not inputting it from the keyboard. So every time I run this program, it's gonna give me an age of what? 10, all right? No matter what I do, it's just gonna take the value that I have and it's gonna output your age is 10. No matter how many times I run it, that's all I'm gonna get, the exact same output. But if I do this, and I really don't have to change age because I'll be overwriting it here, but I'll just take it out. When I run it now, all right, and it asks for age, I could put 100. So all of a sudden now what? Every time I run the program, I can get different results, all right? And sometimes, not all the time, most times when you write code, you want the code to be versatile. Sometimes you don't, because what? When you have a red light and you have software that manages the timing of a light and what light should be on when another light should be off, basically you don't want to change none of that. You want all that to run consistently the same all the time. But then, like I say, sometimes when you're dealing with data and people, many times when you're adding data and deleting data, you would want to be able to control your output because you don't want to get the same output all the time. Say if you have a store, 10 different people come and purchase something from your store. You don't want to be able to just call that that first person that came to your store. You want to be able to have the flexibility to pull up any one of the persons that came into your store that day, right? So that's what the CN allows you to have a program that's more versatile, all right? Now, all right, and it tells you that the C out here asking for a length, okay? Because this is the prompt, all right? Now, the thing is, and they're not really showing it like I think that was Mr. Laws. We were talking about the 4 scores and 7 years. If we look at this program and look at this output here, this says, what is the length of a rectangle, question mark, or well, it did give it, and then double quotes. So what did it give us here? It gave us a space here so that what? When we get our output, when we got our output here, our prompt, to get this prompt, it gave us a space between the question mark and the input. And that's what I want you to be cognizant of when you write in your program. I want you to be to know that, hey, make sure I put a space for readability purposes. All right. So but for the CN, it doesn't matter because it's just pulling in the value. But the output here makes that happen because you got what? One space after the question mark. Same thing for the second one. Let's go back up here. You got one space after the question mark. Well, right here, you got one space after the question mark. Now, another thing is it says the area of the rectangle is, and it has a space. I want you to recognize that too. And look, the area of the rectangle is, and notice it has the space, because if you had the area of the rectangle is, and then 200 right next to this, you know, it would make it, it wouldn't, you can understand it as humans, but it would just make it somewhat a little difficult to read if you got that throughout a document. All right, so you want to kind of stay true to the English language with your spacing, punctuation, and whatnot. All right, so that's what those two statements allow you to do. All right, and it's just telling you. Now notice they're giving you this little guide here. See out streams information into or to the console. Notice where the arrow points to stream in the console. Notice where the directives go. CN, the information will be streamed into that variable. So the directives is going into the variable. And like I said, you might get errors because you may forget, but that's something if you're gonna be coding in C++, you're gonna have to kind of get that stuck in your brain. How what way the directives go for the cout, what way they go for the CN. Because otherwise you're gonna constantly have issues, constantly have problems. Now, entering multiple values, you don't have to only enter one value at a time. You can enter multiple values. But I would tell you, let's give you an example. Let's go back to the program. Okay, int age. Okay, well, and then I could say int age and int year. Okay. And I just use that as purpose, just for whatever purposes. So I want to enter the age, your age, and then I'm gonna input the year you were born. Okay, I just said year. So your current age, and the year you were born. So now I could write the program to where you input the age and what? Cout for the type. Notice the space. All right, so notice in a age, in a year. Now, I'm gonna put a semicolon. So now I have this, and I'll just add to this. I'll put a space here. I don't have to put a space. I'll just add to it. I'll do this. Okay. Okay. You were born in space, and then here I'll put year. All right. Now, so I could ask for that information. And what did I do here? Okay, string. All right, so I have this information here. So I'll input age, input year, and then I can actually print out the age and the year. So let's debug this. All right. Run it in an age. They put 45 in a year. I'll just put what? 1970. Let's say 72. I don't know what, just a year. And hit enter. So look, you're 45 years old. You were born in 1972. I didn't put my period. All right. So I have that information because what? I inputted an age, I inputted a year, right? Two separate inputs, correct? And I hope you get that. Two separate inputs. Now, and the reason I say, because if I give you a program and I say, write a program using one CN statement, That means something like this, all right? I'll take this out. I want to input the year and age, all right? So the book say I could input what? Multiple values, right? And all I have to do is what? CN, stream, age, stream, year. But I cannot just do it, because now my CN statement does not match my what? My Cout statement. My Cout statement says what? Enter your year. So, and let's run it and see what happens. So I'll run this program and say somebody that don't know what the program is about, it says run, and okay, enter your age. Enter your age. Say I'll put 28. Hit enter. What's the program doing? The program is waiting for another input. But my prompt told me just to put what? Just to put an age. So your prompt has to be appropriate for your CN statement. Okay? So when you start writing your code, you as the programmer have to make your prompt for the user, how would I say it? The word that we use in computer science is user-friendly, meaning that it doesn't take much expertise or whatever to figure out what it is you're asking of me. I can flow through the program with limited knowledge of whatever I need to do. Enter age. You just told me to enter the age, but what I need to do, I need to enter the year. So if I put something like this, you were born in 1, because I didn't know what it was asking for. But all I have to do is enter your age and year, born, okay? Now, what I can do here, I can add something to this, okay? Saying that I want to do this, I'll add something to this to kind of give them a little more information so that they can hopefully get it right. So I'll say, enter your age and the year you was born, all right? All right, and then I'll say, separate the two values by space. All right, so now I'm just kind of giving them a little bit more information. Enter your year and age, enter the, how do I say that? Enter your year and enter your age and the year you were born. Separate the two values by a space. So pretty much you're giving it to them, telling them exactly what to do. So now when the program runs, okay, and like I say, as long as the message is clear, all right, it could have been another message. So you're saying, and I need to tab it over. Enter your age and the year you was born. Separate the two values by a space. So it say enter the age, all right? So we put 28 and the year, but it says separate them by a space, all right? And then we put 19, whatever. And look, bam, you are 28 years old. You were born in 1972. So I could have 3 values inputted at one time, 5 values inputted at one time, however many, long as I have the right syntax in my CN statement. All right. So anybody have any questions? All right. Questions? So that's how you input multiple values. All right. Input multiple values. And looking in this program, they just changed up the program. And look, when they change the program, they change their prompt. Enter the length and width of the rectangle. Separated by a space. So now, okay, I need 2 values separated by a space. All right. Now, then what? My CN statement has to match my prompt. So now I do a CN stream length, stream width, because I'm looking for 2 values. Now, and look here, enter length and width. So we know the first value would be length, because if it's something we're doing with length, specifically, we need to know which value to do the CN first on, and the person inputting the data need to know the first value is the length. All right, so that's how you would input multiple values. All right. Now, and then this one just seeing whole, fraction, and letter. So now, this section give you an example of how you can have data misrepresented. Now, what do we mean by that? So here we said where we want to input. Let's see if it did it the other way first, the correct way. Nope, they didn't do it. So here, if we look at this, it says enter an integer, a double, which is double value, and a character, right? Look what they did. They entered 4, which is an integer, right? 5.7, which is a float value or double, and then the letter B. And they got their output. But check this out, and we got to remember, what happens when you take a float value and you store it into an integer value? What happens? Huh, class?
It should go to the one with the highest precedence and make it float.
Well, if we take a float value and input like say assign it or input it into an int value, what happens? A variable.
It takes the whole number?
Correct. It will take that whole number. It's going to truncate the rest. All right. So now we see that they did input an int, they did input a float, and they did input a character. And they what? They're going to get the right value. But what if a person makes a mistake and input 5.7 then as the integer, 4 as the double, and B as the character? What would happen is the computer will take 5 as the what? Integer value, 0.7 as the what? Double value, and 4 as the character. Everybody understand that? Because we done kind of shifted everything because what? We said the first one was an integer. So if the first one is an integer, it's not going to recognize this, okay? So it's going to just take this, then it's going to take the decimal part of that and put in double, and it's going to put the 4 in for a character. Because remember we said numbers can be character data. Now, this is another dilemma. This B here is still lingering in the keyboard buffer. So if you had another CN statement, it will not allow you to input a value. It will say, oh, my keyboard buffer, I still have some information in it. So I'm gonna take that B and put in that next CN statement. And all of a sudden your program's skipping. And you're like, man, why did it skip to the next whatever? Only because the proper data wasn't inputted in the proper order, okay? So you got to be careful of that. That's why many times when people in C++, when they write code, they'll set up everything as string data and convert it once they bring it in so that they can kind of validate it before it's brought in. Like say here, they'll probably bring this in as a string and then check for a decimal place or whatever, and then just take this, check this for a string, and check this and check this because to validate data, or the string data, it'll grab all of this and then it'll try to convert it and ask, is this an integer value or whatever? Is it greater than 5 point whatever? Oh, no, something wrong with the input. And then you'd have to re-input that data to input a whole number. So that's how they kind of control that. But it just tells you in here what would happen. It would have stored 5 into the whole number, 0.7 into the fraction, and 4 into the letter B. I mean, into the character in a variable letter. and then the B would be out there to be used for the next input. Okay, so you got to be mindful when you're doing the multiple CN statements and whatnot. Now, mathematical expressions. We all know how to use mathematical expressions to add, subtract, multiply, divide, etc. And it works the same in C++ or in, say, computer programming. The only difference between math and computer programming is that in computer programming, you cannot revert the expression. I'll give you an example. In computer science, we are in math, let's say math. In math, sum is equal to 21 plus 3. We can solve that, right? We get what? 24, correct? In math, we could say 21 plus 3 equals sum. We could solve that. We still get what? 24. In computer science, the only way we can solve this expression is sum equals 21 plus 3. If we try to revert that and say 21 plus 3 equals sum, we will get an error. No matter what computer program you try to compile in, you will get an error. You say, well, Mr. Vessel, I don't know. I don't think that'll work. Let's check it out. So, and we do this. Say something like, I'll just say int double, db double age. So then I'll say in here, I'll say db age is equal to age times 2. All right? So I'm just doubling the age. All right? And then I could do a C out here. C out. Age doubled. Okay. And db. All right. And this is just something I'm just kind of creating. It ain't nothing dealing with life, whatever. All right, so we have this. So now when we run it, okay, we run it, and I'll put in the age, say 22 and 1989. Okay, putting in some. So age is 22 years, this age double is 44, right? Now, so let's say, well, in math, we could do this the other way too. So what I'll do, I'll take this, all right, and I'll do, all right. Now, let's run. Well, notice we got an error already, but let's run it. Uh-oh, we got an error. So what the error says, okay, expression must be modifiable I value, all right? Now, equal, left operand must be an I value. So what happens is we don't have, this is an expression. An expression can change, all right? I mean, how would I say it? Can't change in a sense. So what happens is, that's like me saying 2 is equal to double age. So I'm taking whatever this is and trying to change this value of 2. 2 can never be changed. So in computer science, you always solve on the right. You solve on the right and assign to the left, always. I don't care what language you use, that's how it's done, okay? Computer science. Like I say, in math, you can revert it and do it, solve it, no problem. But in computer science, this is the way it's done, period. You know, you can't that's why. You can't try to overwrite the compiler. That's the way the compiler, all compilers work. So now, so here we got number equals 3. Now, number is a variable. Number, as long as it's not a constant variable, this is valid. You're taking 3 and storing it into number. Result equal X. That's good, as long as this is not constant. Result equal 4. Now it's equal to 4. Result is equal to 15 divided by 3. No problem. Result is equal to 22 times number. No problem. Solve and then assign. Result equals size of int, which would be 4. Solve, assign. Result is equal to a plus b plus c. Solve this, assign. All right. So that's how the assignment statement works. Okay, with the equal sign. Okay. So now, looking at this. Okay, in a numerator, Cn, in a denominator, your input, the decimal value, and then what? Numerator divided by denominator. And they got their answer. So the division statement can be the slash, which is the divide symbol, can be used also. We can use the plus, we can use the division. All right. Now, we do know that what? When in computer science, there is an order of precedence dealing with operators. Addition and subtraction are on the same level. So it really doesn't matter which one you do first, all right? But when you mix in addition and subtraction with multiplication and division, it can, and you don't use the proper parentheses, you can get a result that you don't really want. Give an example. 17 plus x plus 21 plus y. No matter how you solve this, from left to right, this before this, they all are plus, which have the same precedence, no problem. But when you have, addition and division, all of a sudden now, division has a higher precedence than addition. So what happened is whether you put parentheses around 6 divided by 3 or not, it will perform this first, and then it will add because of the precedence. And down here, we'll look at the chart. Here we got plus and minus as a lower precedence than what? Multiplication, division, and modulus. Then you have a unary negation, which has a higher precedence, meaning to be turned into negative before something happens. All right. So now, like I say, the precedence works. If you don't have parentheses here, it will do it anyway. But if I put parentheses around the 12 and the 6, but then the parentheses take precedence over the operation, because what? I have to solve from within the parentheses and work my way out. Okay. So that's something different. So let's just look at this. 5 plus 2 times 4, what we're going to do first? Multiply, then add. Here we're going to divide first, then subtract. Here we're going to multiply, add, then subtract. Here we're going to do the modulus, then add, then subtract. Here we're going to multiply, subtract, add, and subtract. Now, everybody looking at this, the modulus. What is the modulus symbol? The modulus symbol returns the remainder of an expression, okay? The remainder. So what happens when I use the modulus? So I'll just say module. Okay, I'll just use that. All right. So right here. I ain't gonna use 2. MODU equals, I'll say age modulus, and I'll say 8. I'll just use the number 8. Now, what happens is, and I have to change this to MODU. All right. So what I'm trying to do, I'm trying to find the modulus of age of 8. All right. My age modulus 8. Okay. What does that mean? If age was 8, the modulus of age would be 0. Why is that? 8 goes into 8 how many times? 1 time with what remainder? 0. So 8 modulus 8 is 0. If I had the value 21, the modulus would be 2, all right? Is it 2? No, not 2. 16, it would be,
It'll be 5.
right, it would be 5. Because what? 8 times 2 is 16. It don't go into 21 3 times. It goes into 2. And so what? 21 minus 16 is what? The 5, right? So the remainder. So let's run it. Let's debug it. So we're gonna run the program. I'll put an age in, and let's put in 21 as the age and whatever year. So look, see here, this is the modulus. I got age double. I did that's kind of misleading. So that should be modulus 8. And I'll just put it. All right. So we debug it again, and then I'll put it in. It's 24, I said. I think 24 I put. 25, I think. All right. Oh, yeah, because what? 25 modulus 8 is 1 because 8 goes into 25 how many times? 3 times, right? 8 times 3 is 24 with a remainder of 1, okay? So that's how it works, the remainder. And you got to remember, some students get it confused. The modulus returns the remainder, okay? Because many times we give students a program like to find out if a number is odd or even, all right? So if I'm using the modulus function, how would I determine if a number is odd or even? Using the modulus function.
I divide by 2.
I do the modulus, not the divide. Using the modulus. The number modulus 2. If a number modulus 2 is
0,
then it's, if a number modulus 2 is
1,
then it's
odd.
odd, correct. So you understand what I'm saying? So that's how we can do that, to find out whether a number is what? Odd or even, using that modulus, okay? So let's get back to the note. So we know the precedence. You got to know the precedence. Now, associative principle, as dealing with what? Parentheses. Remember we said what? Always work from the inner of the parentheses outward. So this and this going to give you the same results because what? The plus and the minus have the same precedence, correct? Right? This and this going to give you the same results because of what? Precedence, all right? But when you start mixing those operators of different precedents and with parentheses, it makes a difference. One example would be getting the average of numbers, all right? Normally, and what I'll do, I'll just go back here, and I'll just go down here, and I'll increase the size. Oh, well. Can I increase it? Yeah, I'll increase it. All right, I'll just go down here. So, example, if I had something called average, right? And if I wanted to find the average, well, I got a total, all right? Well, no, I have 5 numbers. I have 10, 100 plus 95 plus 88 plus, well, I'll just use 4 numbers. These 4 numbers, now I know this is an error because it's not dealing with the program. This is dealing with math and the expression. If I have these 4 numbers and I want to find the average, I cannot simply do what? Divide it by 4, correct? Because what? Division has a higher precedence than addition. So what's going to happen? It's going to divide 22 by 4 and get 11, and then it's going to add up all 11 to all of these, which is going to give me a balloon number, right? But if I wanted to find the average of these numbers, I have to group them, all right? All right? Get the sum of all these numbers because what? The parentheses say work from within out. So I'm going to add all these numbers and then divide by 4, and then I would get what? An average, get the correct answer. All right? So just remember that. Like I said, parentheses do play a big part in getting the correct results, and depending on what your scenario is or what the task is that you're working on. So looking at this, 5 plus 2 times 4. What you do, work within the parentheses and then multiply it by 4. Solve within the parentheses. So then you got 10 divided by 5 minus 3. Work within the parentheses and then divide 10 by that result. Here you got 8 plus 12 times 6 minus 2. You work within the parentheses, all right? Then you multiply, not add. Then you multiply times 12. Then you add 8. Because what? Multiplication has a higher precedence than addition. Then look here. Then we have 4 plus 17 modulus 2 minus 1. We're going to do what? Solve within the parentheses. Do the modulus, because modulus has a precedence equal to multiplication and division. And then we're going to subtract. And say here, we got 6 minus 3 times 2 plus 7 divided by 3. So we're going to solve within the parentheses. Solve within the parentheses, multiply, then you start from left to right, multiply, and then divide by 3, and you got your result. All right? So that's how it works. Now, looking at this, in math or an algebraic expression, 6b is equivalent to saying 6 times b, which is equivalent to 6 asterisk b in a computer expression. 3 in parentheses and 12 in parentheses is equivalent to 3 times 12, which in a computer expression in C++ is 3 times asterisk 12. All right? 4xy, all right, is equivalent to saying 4 times x times y, which in C++ is equivalent to doing 4 asterisk x asterisk y. Okay, and I think I've given you all a program dealing with that A and B and whatever, and this is kind of what you can use as that example to write out that expression. 2a as 2 times a, 3ab is 3 times a times b. All right, so those are some of the things that you had to kind of pick up. Now, when converting algebraic expressions to C++, okay, you may have to insert parentheses to make sure your expression does solve correctly. Because what? Looking at this, a plus b is the numerator, right? So you got to solve within the numerator before you what? Try to divide, right? So what? When I write it out in an almost like flat, an expression, one line, I got to do what? A plus b, that's the numerator. And if I had some expression with c times whatever minus whatever, that would also could also be in parentheses to say do this, and then divide by that, rather than just divide that and then do the rest. All right. So that's sometimes you may have to looking at expression. It might not have the parentheses, but you may have to put it to make it understood by the compiler. Okay. So just remember that. And looking at this, 3, then that's say it would be, say what, 3 times what? X over 2. So X over 2, all right, times 3, all right? So that was, so X over 2 times 3. So here we got ABC, so that's what? 3ABC plus 4. So that's 3 times A times, 3 times B times C plus 4. So you really don't need no parentheses because this have a higher precedence, and then it's going to do this. All right. If you had something else over here, that would depend. All right. Now, here you have a numerator and you have a denominator, as I said before. So what? You do everything on the numerator, then you do everything with the denominator, and then you solve. Work from within out. But then what? Multiply, then add. Multiply, then subtract. And then what? Divide this into this. Okay? All right. Now, in C++ and most any language, you cannot just write an expression with an exponent in it. You can't do it. So most applications have functions that's built in within it so that you can use the power function. So if you notice, we have something called POW, which is the power function. Now, you can't just use the power function in C++. You're going to have to load the math library. So what I'll do, I'll take this off. I'll reduce this size. And notice, I'll take this off and I'll say, I'll use this. I'll just say power. Okay, POW, H, comma 2. All right. But what happens? I still have an error. Well, no, I need a new power. Oh, power is done. I changed this to power. I thought I would need the math library. All right. Okay. So it looks like I don't need the math library, but normally I would need the math library power. Okay, so let's debug this. And well, let's see. Oh, power 2. That means squared. So what I'll do the debug, and for age, I thought I would get an error. No, I'll put age. I'll put 3, and then I'll put what? 2000. This is 2000 what? 2020. I'll say 17. All right. And then, so look what happened. I still have the wrong, misleading prompt. But what? 3 squared is what? 9. All right. Okay, so I'll just say age. Okay. All right, age power of 2. All right, so let's run it again. Debug, and let's say this time I'll put 10. All right, 10. All right, and hit enter. See, 10 times 10 or 10 squared is 100. So see, you can use functions, all right, in your program. So if I needed to do an expression, I'd have to know what? How to put that power function in my expression. So look at this. Area is equal to 4 squared. That would be, like we just did, power is equal to age squared. Power is equal to POW, parentheses, 4, comma 2, right? So looking at this one, X is equal to the power of 6 to the 3rd. So that's 6 cubed. 6 times 6 is, what's 6 times 6? 36 times 6. I don't know what that number is. Then you multiply it times 3, and that will give you X. All right? So you would be raising 6 to the 3rd power and then multiplying times 3. Here you would be raising 5 to the 4th power. 5 times 5 is 25. Times 5 is whatever times 5. So that's what you would get, 5 raised to the 4th power. All right? So that's all that's saying. And that's how that function works. All right? Now, and see here, what they did is, here is a standard area function, pi r squared. What they did in the program, pi may have been set to a constant value. So when they wrote the expression, pi times the power of r, which would be the radius, 2. So the radius raised to the 2nd power times 3.14, going to give you the area. So sometimes you're going to have to kind of know how to write out your expression to fit the power function, because you cannot just put an exponent as a character in a program. All right, and so it's showing this. So this would be the answer. But what it's showing you, constant pi, which is pi, and 3.14159, and then what? You're gonna have a area and a radius. So they allow them to input a radius. Okay. So now pi is known, the radius is known, Now we can square the radius, multiply times pi, and we get the area. Okay? All right. So, let's see. All right. So, when you mix apples and oranges, okay, dealing with type conversions, all right? So you got long, double, float, unsigned, long, unsigned, in. All right. So when an operator's operands are of different data types, C++ will automatically convert them to the same data type. I don't know if it was this class when we took the letter A as a char and we stored it into an int value. It says, okay, I can't store the letter A, so I'll convert the letter A to 65 to its numeric value, and then it'll print out 65. So that's what it's saying. C++, what it does when you have values of operands, which are your variables of different data types, it will automatically convert them to the same data type so that it can solve an expression. All right. So if an int is multiplied times a float, it's gonna be promoted. All right. Your result, the data type. What data type will it result? Well, it's gonna be promoted. Okay. What if the double is divided by an unsigned int? Is there any way to predict what will happen to these in these instances? Yes. All right. And the answer is yes. C++ follows a set of rules for performing mathematical operations on variables of different data types. It's helpful to understand these rules to prevent subtle errors from creeping into your program. So it could be your program is running correctly, it's executing expressions correctly, but giving you the wrong output. Right? It is helpful to understand these rules to prevent, okay, we said that subtle errors creeping in. Just like officers in the military, data types are ranked, okay? So we talked about it. So yeah, that's the ranking. It's helpful to understand these, that's my third time reading that question. So one data type outranks another if it can hold a larger number, all right? And remember we went over those numbers where we said short was a smaller data type than int, which is a shorter data type than long int, all right? Then you had float and double and long double, all right? So this table shows you that an int is smaller than the long int, smaller than a float, smaller than a double, smaller than a long double, and even with your unsigned and signed. All right. So looking at this, all right, you will notice that char and short and unsigned short do not appear in the table. Okay, that's because anytime they're used in a mathematical expression, they are automatically promoted to int. Right? So they are int, but they just said, okay, we just gonna make them int, and it's still the same data type of int. All right. The only exception to this rule is when an unsigned short holds a value larger than is held in an int. Okay. This can happen on systems where shorts are the same size as int, because short really holds 2 bytes. Okay. Short data is stored in 2 bytes on the typical system, and int is stored in 4 bytes, which gives you a larger range of values to be stored in that data type. But when short and int is of the same data type, then it falls in that category what we just talked about. So that's one of the rules. In this case, the unsigned short is promoted to unsigned int. All right. So now, when an operator works with 2 values of different data types, the lower ranking value is promoted to the type of the higher ranking value. And we did that when we did one number int divided by a float. Int divided by a float it will be promoted to a float output. But if it's stored into an int, it reverts back. It's gonna just store the int value, okay? But it will calculate the float part of it. So before the multiplication takes place, years will be promoted to float so that you can get a float result. In the third rule, when the final value of an expression is assigned to a variable, it will be converted to the data type of that variable, because just like I said, if it's a float on the left side, it'll take that float value if it's promoted to float. If it's an int, it's only gonna take that int value because that's all that can be stored at that address. Okay, so that's very, 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 very important. So that's basically what all that is saying. All right, it will be promoted. Like, look at this: int x y equals 4, float z equals 2.7. But then y times z is going to be stored. What type value you going to be storing in the x? An int value. I don't care how many decimal places you have after. It's just going to store an int into that x, an int value into that x. Now, so it will have a float value of 2.7 here, right? But now you got an int and a float. It's going to be promoted to a float, but it's going to be stored as an int into an int. All right, so that's all that's saying. Now, integer division. All right, when you divide an integer by another number in C++, the result is always integer. All right, and we said that too. Remember, and you'd had that on the test. If you had 18 divided by 4, you'd automatically get an int. But if it's an int on this side, that's all it stores. Even if it was float on this side, it will store the number and, like I say, a whole number, because the decimal point will be 0.0. All right. But if any one of these was float or double, like say 0.0, like 15 divided by 6.0, it's promoted to double and it's stored into double. All right. But int divided by int gonna yield an int, and it's gonna store int value here. You can output the value with a decimal place, but it's gonna just put 0.0 or 0.000, because anything out of that would be truncated. All right. So it's telling you now, when you do this, all of a sudden it's promoted. That same thing is saying it promoted. Now you can get whatever, if it's 2.333305, whatever, it'll give you that value, and now you can output that decimal. All right. All right. Overflow and underflow. When a variable is assigned a value that is too large or too small. Remember, we just talked about our range of data. Remember, an int value has 4 bytes. The range of the numbers that can be stored in those 4 bytes is a negative 32,000 and something to a positive 32,000 and something. I think it's 32 or 36. But anyway, so your number cannot be less than that negative number, and it cannot be greater than that positive number. So if it is greater than that positive number, C++ allows the system to loop back and start back at that negative number, incrementing the number of times it needs to based on the value. And we'll see that in the program in a little while. So you got to be careful when you're giving or assigning data types to make sure that a value that you're trying to retrieve and store in a variable has the right, or is the right size to store the value that you're trying to store into it. So look at this program here, and as an example as what I'm just trying to say. If we take, move this out of the way. So if we take this program, looking at this program, it set test var to 32,000. 32,767. That's the highest value that can be stored in a short data type, okay, of 2 bytes, okay? 32,767. Now, what they did was they outputted the test var value, which is 32,767. But look what they did after that. They incremented it by one number, and then they outputted it. All right. So they incremented it by 1 and outputted that same variable. All right. It outputted that same variable, but look what the value is. Negative 32,768. So what happened? Being that the data type was short, and we was up to the limit in the value that we could store in that memory location, and we bumped it up by 1, it overflowed and said, okay, I cannot make it equal to 32,768. I have to go back and loop back to that negative, the beginning side, that negative side, and start there from that first position, second position, third, but that first position, which is what? 32,768. So if I try to display that value, adding 1 to it, all of a sudden, I won't get the right output, all right? So that's what they're talking about with overflow, all right? And then all they did was subtracted 1 from it again, from that the way it was incremented by 1, they subtracted 1, and then they printed out the value, and then it went back to the value, the high value that could be stored. So as long as for a short, as long as the value that you're trying to store into that variable is less than or equal to 32,767 and greater than 32,768, you don't have an issue with that number. But if it's less than that or greater than that, you will have a problem. Okay, that's all it's changing with that overflow. All right, so that's all it's saying. Now, let's look at typecasting. All right, what typecasting does, it allows you to take a value or variable of one data type and use it as another data type. Okay, so look what happened here. We had double number. Number is the variable. Well, let's go back to the typecast. Typecasting allows you to perform manual data conversion. All right, so that's all you're doing. Rather, you can declare something to be of whatever data type, and you the programmer can say, okay, at this time I want to use this variable as this data type. It's not changing it or anything, but you're using it as a different data type, and then moving on with your program. So look here, it says the typecast expression lets you manually promote or demote a value. So you can go in, float, whatever, however you want to do it. Short, whatever, it's on you, the programmer. The general format of a typecast expression is static _ cast, whatever data type you want to cast it to, and then the value or the variable that you use. All right. So let's look at this. It says double number is equal to 3.7. So it allocated memory for a number, and it's storing 3.7 in that memory location. But look what they did. They declared a variable called val of integer. So now only an integer value can be stored in val. So what did they do? They said, okay, val is equal to static cast int number. So when we did int number here, we did the static cast first. It says take that number, change the data type to int, right? For whatever the value is equal to, and store it into val, all right? So now it's going to store what in the val? 3, because what? Val is int. You say do the static cast of number, which is int, so it's going to take the 3 and put into val, all right? But you could have did the same thing as saying number, a val is equal to number, because if this is int, it would say what? Take the 3 and put in, truncate the rest. But it's just showing you how you can do a static cast and say, okay, make number int and then store it in the here. All right? So it tells us this code defines 2 variables, number, which are a double, and val and int. The static cast, the typecast expression in the third statement returns a copy of the value of number converted to an int. So when a double is converted to an int, the fractional part is what? Truncated. Got to remember that. It's truncated when you're storing it into an int. So what? Like I say, doing this statement is equivalent just to saying val is equal to number, because it would do the exact same thing. It would take the 3 and store it in the here. Okay? Now, so it says the typecast expressions are useful in situations where C++ will perform a desired conversion automatically, right? Such as, look at this, per month, static type, static cast book, static cast double book / month. Now, book is declared as what? An int. Month is declared as a what? Int. So if we look down here, if we wanted to get a true number of the average books students read per month, like 3.5, 1.75, 4.25, rather than 4, 3, 5, 7, 12, we getting decimal places. What they did was they say, okay, enter the number of books they read. Say they read 10 books, and then in 3 months. So that's what? 3.33333, right? So when you did the static cast of double here on books, which is int, you just promoted that expression to be double, because what? Int and double, I'm promoting it. Now when I divide books by months, I'm gonna get 3.333, and per month is of double, and now I can get my average value. So you understand how that static cast allowed me to take that variable, change it, use it as a different data type without affecting the actual variable itself, and then get my result that I needed. So if we look at this program, they read 30 books and in 7 months. But if we didn't have static cast in this formula here, in this expression, we would get 4. Simple as that. We'll just get the number 4. But given that we use static cast to promote, because we got double divided by our int, we promoting this side of the function of the expression now, and storing it into a double. Now we can get 4.28571. Okay? Any questions? So we'll stop right here, class, because I see the class is ended. Any questions so far? Questions? Hello? Now, what I might do, we're gonna finish the we're gonna finish up on the chapter on next class period. But what I'll do, I think I got a couple of quizzes that I'll post for you to take. All right, make sure you take them though. And then we'll finish up on this section on next class period. And know they got set precision, and that's all dealing with the IO man IP header file. All right, and then also have the set W, which set the column width. and stuff like that. And then not scientific notation. They talk about it, but I'm talking about the decimal places, all right, that you can set significant digits and all that. So we'll talk about that on next class period. Anybody have any questions? Any questions? And then the left and right, that's something else also. Any questions? If not, I'll see you on next class period, and I'll post the little quizzes that we're gonna do. All right? Yeah, all right. Yeah. Keyboard buffering. We'll talk about that next class period. We kind of talked about it, but we'll talk about that next class period. All right. Math library. That's the math functions you can use. Square root and all that. We'll talk about that. Random numbers. And I think that's the end of the chapter. But like I said, we'll cover the chapter. And that's debugging. That's just something on programming style and whatnot. But that's a good feature to know, keeping track of your variables as your program progresses. All right. So next class period we'll deal with that, and like I say, study, review your chapters, because after next class period we'll have a test. All right. Okay.
Yes, sir.
All right. So see y'all on next class period. All right. And I think I got to grade y'all assignment because y'all did do a project, right? All right. Okay. So have a good one.
You as well.
All right. Bye-bye.